Hello, everyone, and welcome to our virtual Lunch and Learn. Today, we're talking about the Kinetix 5100 product release. My name is Leanne Ireland, and I'm the Corporate Marketing Project Manager here at McNaughton-McKay Electric Company. Presenting for us today is Steve McDonald, Systems Engineer with the Drives and Mechanical Group in our McNaughton-McKay Madison Heights location. Out in the comments section, ready to answer your questions, is Nathan Nicholas, Systems Engineer Supervisor for the Michigan region. We'll also have a question and answer portion at the end for Steve to answer your questions in more depth. We'll be getting started shortly, but we like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments. Continue to socially distance, we're happy to be able to host these live sessions on YouTube, making it possible for you to be able to join us from the comfort and safety of your own homes and offices. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we will be continuing this series every Wednesday at noon, so be sure to join us on your lunch break. For anyone just joining us, welcome to our virtual Lunch and Learn Kinetix 5100 product release. Let us know where you're joining us from in the comments. We'll be looking for questions as you have them in the comments while our presenter, Steve McDonald, gives an overview of the new Kinetix 5100 drive family and how it will make your machines more competitive and productive. Our specialist, Nathan, will do his best to respond to your questions in the comments as we go along. And we'll also have a Q&A segment at the end of Steve's presentation to address some of those questions in more depth and to allow some time for any follow-up questions you might have. If you'd like to reach out to us afterwards, or if you have further questions for Steve, you can send us an email at macandmaclive@mc-mc.com. Be sure to let us know which session you attended, and we'll direct your questions to Steve. We'll have the email address on the screen for you at the end as well. It looks like we have quite a few attendees now, so let's get started. Steve, I'll pass it over to you now.
Thank you, Leanne. Welcome. Thank you for spending your lunch hour with us. I'm Steve McDonald, a systems engineer in the Drive, Motion, and Mechanical Group with McNaughton-McKay in southeastern Michigan. Let's take a look at the agenda. We'll start with the Kinetix 5100 system overview, then we'll dig into more detail on the drive. After the drive, we'll look at the TLP motor series and cables, and a few quick slides on the free tools Rockwell provides for sizing and selection. Then we'll get into the fun part, the software. We'll set up an index with Connected Components Workbench version 12 with a Micro 850 PLC and review the code in a Studio 5000 environment. As promised, the overview. Currently available is the 100 and 200 volt single phase and 200 volt three-phase drives. Soon we should see the release of the 400 volt class drives and motors. The Kinetix 5100 benefits include easy system sizing. We'll get into more detail on the drive and motor sizing in future slides. Backward compatibility currently supports MPL motors for customers migrating from Ultra 3000s due to end of life, or the active Kinetix 300 models as needed for your applications. This year, we should see TL and TLY support for the Kinetix 5100 also. Very cost competitive, designed to run standalone with Micro 800 PLCs, discrete, or with Compact Logics or Control Logics processors. Target applications. Here are some example applications designed to be easy to select, easy to use, cost-effective, yet full of features. The drive will run simple speed control, torque control, indexing, even advanced features like gearing and camming. Now let's take a look at the drive details. Some key features of the Kinetix 5100 drive: hardwired STO or safe torque off, onboard I/O, 10 digital in and 5 digital out, 2 analog in and 2 analog out. These are all configurable. 2 fast digital in also. Auxiliary feedback port for second encoder or other feedback device for dual loop control as needed for your application. Currently runs the MP and TLP series motors. Soon there'll be support for the TL and TLY series as discussed before. Remember, the 200 volt class motors, the MPA series currently. Soon, the 400 volt class motors, the MPB series. There's a solid set of add-on instructions available for download from the Rockwell PCDC. If you're familiar with Rockwell sit motion commands, these add-on instructions will look and feel the same. Enhanced auto-tuning vibration features, enhanced auto-tuning and vibration reduction features. The drive comes standard with dual port Ethernet for daisy chaining or DLR device level ring. Here's where the Kinetix 5100 sits in the Kinetix 5000 class family. Kinetix 5100, great for use on standalone or lower access count machines. Use it with micro 800s, compact logics, or standalone, discrete, pulse train output, or analog. Coming soon, the Kinetix 5300 will add entry-level sit motion for low access count machines. Next up, we have the Kinetix 5500. This has support for single cable VPL motors and network-based safety options for medium-sized machines with lower access count. Next, we have the workhorse of the Kinetix line, the Kinetix 5700, for higher access count or higher performance applications. This also adds advanced safety and regen power capability. Contact your local rep if you need specific application guidance for which Kinetix drive to select. Now let's get back to the main topic, the Kinetix 5100. There are 8 sizes, 6 frames, up to 2 kilowatt drives. You can run 95 to 132 volts AC single phase with reduced output power, or 170 to 253 volts AC single phase, or the whole range of drives. You can run 170 to 253 volts 3-phase input power today. Once again, there will be a 400 volt class input of the Kinetix 5100s out soon. The smallest 0.4 kilowatt drive shown on the left is 1.3 inches wide and under 7 inches tall on the frame 1. And the largest frame 7 is just over 7 inches wide and 15 inches tall, very compact for a powerful 15 kilowatt drive. Here's the layout of the connections on the 1, 3, and 6 frame drives. You see the smaller frame uses the top, front, and bottom for connections, and the larger frames have enough real estate to have all of the connections on the front for easy access. Dual Ethernet ports, mini USB for programming, I/O connection. Don't forget the 2198 TB-IO 50-pin I/O connector as needed for your application. You need the connector if you plan to run the drive standalone. Auxiliary feedback port for a second encoder, motor grounding plate for attaching the shield of the motor cable to the drive. Now let's take a look at the Kinetix 5100 catalog structure. The Ultra 3000s are 2098. The Kinetix 300s are 2097. And then in the 5000 class, the Kinetix 5500s are 2198H. The Kinetix 5700s are 2198S for single axis and D for dual axis. And the Kinetix 5100s are 2198E for EIP. Soon you'll have the Kinetix 5300 at 2198C for SIP motion. Then you have your currently today the 2 voltage classes, the power rating, and the hardwired STO only. Now let's talk about the TLP motor. The TLP motor range goes over 17 times larger on continuous torque and 14 times larger on peak torque than the TL and TLY motors. This gives you a far greater power range and far better coverage in the lower axis count machines. Flexibility in torque and speed gives you a better motor selection for your application. Currently, there are 18 TLP motors and 23 MPL motors to choose from for the Kinetix 5100. When the 400 volt AC class comes out, there will be many more. The Kinetix 5100 gives you another active option in the standalone drive class. As noted earlier, the TLP motor has wide product coverage. The mounting flange is designed for TL or TLY migration. We will get into the cable details more in upcoming slides. 24-bit absolute encoder with multi-turn capability. The motor part number starts with the series like previous motors. The TLP series has similar voltage designator as the MPL and VPL motors. You have an A for the 200 class, 200 volt class motors, and a B for the 400 volt class motors. Then you have the frame size. And now instead of stack length and rated speed ladder, you have the rated power of the motor. Feedback, currently D is the only option for the 24-bit single or multi-turn encoder. J for key shaft and K for smooth shaft, like previous motor models. The connectors, rectangular with a 0.3 or 1 meter cable, or military style for the larger frame motors. Brake, as before, 2 for no brake, 4 for a 24 volt DC brake. And finally, factory options, A for no shaft seal and S for seal. TLP cables. 2090C is the number designator for all Kinetix cables. Cable type power with brake, power without brake, feedback, or just the brake cable. Motor cables are flying leads on the drive end with power wires going to terminals, and feedback will be a 15-pin D-sub connector for the TLP motor. The largest 2 motors, you have a separate brake cable. Extension cables are also available in 3, 5, and 10 meter cable lengths. The next value will be the wired gauge for power cables, or CF for feedback. Then flex or non-flex, and the length in meters. Now let's briefly look at some of the tools available for system design from Rockwell. The Kinetix 5100 is on Motion Analyzer today. Motion Analyzer online today. Motion Analyzer is a very powerful sizing application. It's free to use. There's no software to install on your computer. You can create applications and share them between departments, like between mechanical and controls. You can also share them with your customer. At McNaughton-McKay, we create Motion Analyzer applications daily. Sometimes we share them with customers. Sometimes customers share them with us for review. Another tool is ProposalWorks. It's a free software that helps you build your system. This requires a download, but it is well worth it. It is an up-to-date catalog of all of the Rockwell and some Encompass partner part numbers. And finally, a list of the publications currently out for the Kinetix 5100. The selection guide, technical data, and user manual have everything you need to design and implement your Servo system. Now let's take a look at what it takes to make one move. First, we'll start with the Micro 850 PLC. Kinetix 5100C software is available for download on the Rockwell PCDC website. We can start a new application. Call it Project 9. As you can see, it's already grabbed my COM port. I've plugged into the drive with a USB cable. We'll add this to the project. We can go on with line with the drive. We'll download all the parameters as a basic program. Now we're online with the drive. We'll change it to position mode for PR, position register, for our index. Now that we're in position register mode, we'll set our drive IP address. We'll set this IP address to 20. Now we'll go into our motor selection. We'll select motor NV as the default. That's for motor non-volatile memory. This will go out and look at the motor and encoder and bring it into our application. At this time, you can change the overload limit if required. We won't need to change that today. All default values. Next again. Now we can download this to the drive. Currently, it's in emergency stop. Downloaded it to the drive. Auto identify is completed. Sees our encoder. Now we can close our motor. Now we can go into our position register mode editor. We'll go to our position register 1. We'll set this to a point-to-point command. We'll make it a relative for today. You can also do an absolute move. We'll make it 500 counts. Download that to the drive. Download OK. Now finally, we'll set up our digital I/O. And our digital I/O for today, we'll edit our I/O configuration. We'll change our servo on to a normally closed. And then the rest of the inputs we'll disable. Don't forget to hit OK because it will revert back. The most important ones are these over travels and the emergency stop signal. Now you see our servo is enabled because we had an emergency stop before. We'll reset the fault. Servo is ready and at 0 speed. Now we can switch over to the Connected Component Workbench. We'll create a new application and call it Live Demo. We'll add our controller. Today we're using a Micrologix 850, 24 QBB. Add it to the project. While we're here, we'll set our Ethernet IP address, and that was 20. 20. Subnet mask will automatically populate. And here is where we'll import Exchange file. This file was downloaded from the Rockwell sample code website. It's our Kinetix 51 index command. This brings in everything we need, our user-defined function block. We can also create a couple variables. We'll create a toggle bit, and we'll create a servo index. Add a new program. Open our program. Now we can start writing our code. This will be our toggle bit, our controller, servo index. Add one more run. Now you'll see our user-defined block has been brought in here. Single click. Let's view our properties and make this wider so we can see our block. On our block, our first item is our IP address string. That's 192.168.1.20 is our drive address. The index was index 1. Command servo on, we're running that through, we're forcing that on. Servo off we won't need. Run index. We'll put our index in. And that's all we need. Now we can connect to the drive, connect to the PLC. I'm connected over USB. Download current project to the controller. Yes, we'll overwrite the program that's in it. Download complete, change it to run mode. So, 192.168.120. One 192.168.120. IP address conflict. Well, regardless, if there wasn't an IP address conflict, this is all of the code required to index the Kinetix 5100 with a micro 850. Let's move over to the code for Studio 5000. So first, on our Kinetix 5100, we need to change from PR to IO. Download the IO mode. Now we can start a new application for our Compact Logix PLC. Today we'll use an L18. We'll just call it demo. Zero modules. Create our new application. We'll start by bringing in our user-defined data types. Import data type. These were downloaded from the Rockwell PCDC website also. We'll bring in all three data types. Now that we have our required data types, we can bring in our add-on instructions as needed. The only add-on instruction that we need for today is the motion axis index, or the MAI. You have fault reset, motion axis gear, home, jog, move, as you would in a typical SIP processor. So now we have our add-on instructions and we have our UDTs. Let's add our device to the tree. If you're using Studio version 30, 31, or 32, you'll need to download the add-on profile from the Rockwell PCDC website. If you're using version 33, that will be there. You can type in 2198-E for our Kinetix 5100 drives. Today we have a 0.75 kW drive. Double click, or you can hit create. Give it a name, an IP address, now we have our drive, we have our add-on instruction. We can start creating our logic. For today, we'll just put it in the main routine. First thing that we need to do is bring in a CPS. The source will be our Kinetix 5100 inputs. The destination will be a new file, a new tag that we create for a length of 1. Create this new. The data type will be an R for our Kinetix 5100 UDT assembly data. Now that that's created, we'll make that the input. For a length of 1. And while we're here, We'll create the output. So we can change this to O. Move it down here. That'll be our K5100 output I/O. That'll take the outputs from the processor and send them to the drive. And now we need our, throw in a toggle bit, and then we can throw our add-on instruction, our motion access index. Don't need those or that. Toggle 1. New Boolean. Now this will be a new tag you create. We'll call that MAI_1. And since we're creating it in the MAI block, it knows the data type is MAI. Create that. Grab our reference axis, which is our Kinetix 5100. And the index that we're going to modify is index 1. And that's all it takes to create an index with a compact or control logics processor. Thank you for your time, your lunch hour. Reach out to your local Rockwell distributor for more information. Leanne, it's all yours.
Thank you, Steve. You did a great job. We do have one question for you, and this is coming from Alan. And he wants, and there are two parts to this question, Steve. And one of it where he asks to show an example. I'm not sure if you're going to be able to do that today. So the question is, how does the pulse train input signal work? And can you show a quick example of that in the software? I don't know if that's something that you can do quickly or not. So we may have to get back to Alan.
Yes, that'd probably be more in depth, but I would be happy to create it and send it to him.
Okay, so Alan, if you can send us an email at macandmaclive@mc-mc.com with your email and contact information, then we can either have Steve reach out to you, or I see you're from Bucyrus. I'll have one of the Ohio guys reach out to you as well. Do we have any other questions for Steve out there? While we wait to see if anyone has any follow-up questions, I'd like to reiterate to you that you can reach out to us into the same email address that I just dropped into the chat, and macandmaclive@mc-mc.com. We'll make sure that your question is passed along to Steve, who can respond to you directly. Just be sure to let us know the name of this session in your email, which is the Kinetix 5100 product release. Steve, to let you know, Alan said that he would reach out to you, so we'll be with him shortly with that information.
Fantastic.
Well, I don't think we have any more questions. Thank you, Steve, for all your hard work today. And everyone out there, we hope that this session was informative and engaging for you. For next week's section, I just wanted to let you know, next week's section for the virtual Lunch and Learn will be McNaughton-McKay and Rockwell Automation Services and Support. You can remember to subscribe to our YouTube channel for industry content, and we look forward to seeing you live again next week. Thank you so much and have a great day.
Thank you.